All right, guys. So what we're doing today is going over 2.3. So 2.3 is identifying and interpreting relative key features. So we have our first example. We're gonna just go ahead and jump right in with our intercepts. So our intercepts are points where we cross the x-axis. So our x-axis is this guy here, and I touch it not once, but 2 times. So all we want for the x-intercepts are gonna be x equals -3 and x equals +1. Again, all I was looking for was where I touch that x-axis. Similarly, my y-intercept is again going to be where I touch my y-axis, and I touch my y-axis here. So now my y-intercept is going to be y equals 3. Right, so intercepts, you can think of it as like an intersection. It's where I'm touching that axis. All right, when we're asking ourselves if it's a positive or negative graph, the way I teach my kids is a positive graph looks like a happy face, right? Positive, positivity. A negative graph looks like a sad face. So in this case, we have a negative graph because we have a sad face, he's opening down. So we'll just go ahead and click negative. When it comes to domain, really all you need to ask yourself is how far to the left am I going? So I know that my graph has some shape like this. It's going to go down and to the left, down and to the left, down to the left, down to the left. That arrow means it's going down and to the left forever and ever and ever. So it's never, ever, ever going to stop going to the left. I know to the left I have negative infinity. So I'm going all the way to negative infinity. And similarly, in the right-hand side, I'm going to keep going down and to the right forever and ever, ever. Right? I'm going to keep going right. I'm going to keep going along this axis all the way to positive infinity. So if I never stop going to the right, I'm going to go all the way to positive infinity. We'll go to the intervals in a second. Before I talk about intervals, I like to talk about the vertex. So the vertex is here, and the vertex represents where our graph changes direction, right? Let me clean this up a little bit. If you look at the shape of the graph, you can kind of separate them into 2 areas. We have this area here in green, and then we have our vertex. And our vertex is -1, 4. And then after we hit that vertex, what we start to do is we start to go down. So our quadratics have 2 very distinct areas. And we're going to need those when we talk about our increasing and decreasing intervals. Like we said, our vertex is where we change between direction. So my vertex is going to be -1, 4. That vertex is a maximum because that's the highest the graph will go. I can't have a y value that's larger than 4. I can't go all the way up here to where y is 5 or where y is 10. My graph is completely below that. So I know that I have a maximum. Okay, so what I like to do with the intervals of increasing and decreasing is write out my domain and then separate my domain based on the x value of the vertex. So the x value of my vertex in this case is going to be -1. So I'm going to throw a -1 here, and I'm going to throw a -1 there. What I did was I just separated my domain into 2 parts, 2 regions. Those 2 regions represent the left-hand side and the right-hand side of the vertex. So if I look at the left-hand side, which I highlighted in green already, so this is the left-hand side. When I go from left to right, my graph is going up. So my graph is increasing. So I know this section of the domain is going up, it's increasing. So I'm going to write that here in my increasing interval. Again, it was my domain separated by the x value of my vertex. And that's the same thing with my interval of decreasing. So I start decreasing on this yellow side. As I move to the right, I go down. As I move to the right, I go down. As I move to the right, I go down. And I started decreasing at that vertex. So I started decreasing when x was -1, and then I never ever stopped decreasing. So I went all the way up to infinity decreasing. End behavior, the hardest thing about end behavior is understanding like how to read it. End behavior is really just asking As you move to the right, where does my graph go? Well, I see as I move to the right, I'm going further and further down. And I'm going to go all the way down to negative infinity. That's also true on the left-hand side. As I move in the left direction, so as I go this way, my graph still is going down. So I'm going to put negative infinity here as well. So again, intercepts, where do you touch those axes? Positive and negative, is it a happy face or a sad face? Your domain, how far left, how far right? For your intervals, which is probably the hardest part, you want to write out your domain and just separate the domain based on the x value of the vertex. That's going to be key. All right, let me clean it up. Let's go forward. So average rate of change is, again, just algebra 2 version of slope. Remember, slope, all we're looking at is y2 minus y1 over x2 minus x1. You can also look at it from the graph and just do rise over run, totally up to you. When my x is -3, my y is 0. And when my x is -1, my y is 4. So I know my y2, my second y value, is going to be this 4 here. Because this is my first point and this is my second point, which makes this x1, y1, and this x2, y2. So I'm just going to go ahead and erase this y2, and in its place, I'm going to write 4. And then again, I'm erasing my y1, and in its place, I'm putting my first y value, which in this case was 0. Looking for my second x value, which was -1, and then my first x value, which was -3. 4 minus 0 is a piece of cake, it's just 4. When you have a negative and a negative, remember that that makes it +3. So we have +4 over 2, which is really just 2. So the average rate of change from x equals -3 to x equals -1 is just going to be 2. Again, I know it's +2 because if I look at the graph, I'm increasing. The other thing you could have done is just looked at the change in y over the change in x. So it goes up 1, 2, 3, 4 over 1, 2. So up 4 over 2. Totally up to you which method you choose. So now this is our second example. Again, if it helps, draw arrows on here. My x-intercepts, all I want to know is when am I touching that x-axis. So I'm going to go ahead and highlight my x-axis. I touch it 2 times. I touch it here when x is 0 and here when x is 2. And then the way we have this written is kind of interesting for when we look at the y-intercept, because my y-intercept is when I touch my blue line or my y-axis. As it turns out, I have that point, which is where I'm touching the y-axis, which is the same point that I had as an x-intercept. That point is called the origin. It's 0, 0. And if I am at that point, then I do in fact have both an x-intercept and a y-intercept at 0, 0. So that's kind of fun. Let's go ahead and talk about our domain. Again, our domain is how far to the left is my, or I'm sorry, let's go ahead and talk about whether or not it's positive or negative. So does it make a happy face, meaning positive, or does it make a sad face, meaning negative? Well, we look up here and it's a happy face. It opens up, it's positive. All right, so let's take a look at our domain. If I'm going along my x-axis, I know that I can keep going on forever and my graph will still be there. My graph may be super positive and not even on the axis, but it's still there. All right, that's what that arrow is telling me, that I can go up and to the left forever and ever and ever. And if we look at our number line, all the way to the left is going to be negative infinity. So my domain is, again, negative infinity. I can continue going in the right direction as well. That's what that arrow is telling me. I'm going to go up and to the right, up and to the right, up and to the right. And I'm never going to stop going up and to the right. Because I'm going to the right all the way, I'm looking at positive infinity. Okay, increasing interval, decreasing interval. What we're going to do is we're going to separate our domain. Let me clean this up a little bit. So we're going to separate our domain based on the vertex. So let's just go ahead and look at our vertex. Our vertex is where our graph changes like direction. So I know if I highlight from the left-hand side, I'm going down, 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 down. And then I hit this point. That point is 1, -3. After I hit that point, something weird happens. Once I cross that point, I'm in a new region of my graph because now I'm starting to go up, up, up. That's what the vertex means. That's what extrema means. It means my graph is changing direction. So my vertex is going to be 1, -3. I know it's a minimum because my graph doesn't go any lower. Like I can't go to where y is -4 or y is -10. So that's the lowest my graph will go. All right, separate your domain. Our domain is -infinity to +infinity, and we're going to put the x value of the vertex in that region. So the x value of the vertex is 1. So we're going to go ahead and put 1s there. The first interval I have represents the left-hand side, so it represents the green, which means all we need to do is determine, is the green side increasing or decreasing? So as I go to the right, I'm going down. As I go to the right, I'm going down. As I go to the right, I'm going down, which means the green side is in fact decreasing. Whereas on my yellow side, as I move to the right, I go up, 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 which makes this increasing. So my second interval there is my increasing interval. So my increasing interval started at 1, where my vertex was, and never ever ended. So it's going to go all the way to +infinity. My decreasing interval started all the way on the left and ended when x is 1 at that vertex. End behavior, all you need to know is as I move to the right, where is it going? Well, as I move further and further to the right, my graph is going further and further up, right? So it doesn't matter how far to the right I go, I'm going to go closer and closer to +infinity. That's what those arrows mean. It means I'm going closer and closer. I'm never going to stop until I reach it. Similarly, as I go to the left, I'm going up, up, and up, and up, and up, all the way to +infinity. So that's what we're looking for. We're going to go ahead and go over average rate of change. Let's just do this one. I like to do it algebraically. So we have y2 minus y1 over x2 minus x1. So we have the point here when x is 0, that's the coordinate pair 0, 0. And then we have when x is 1, which is down here. So that's coordinate pair 1, -3. Again, we read left to right. So this is our first one. This is our second one. Again, it's just going left to right. So my second y value is -3. And then what's my first y value? So my first y value should have been 0. And then my second x value would have been 1, because I'm going to my second pair and looking for the x value. Under the same logic, my first x value should have been 0. -3 minus 0 is -3. 1 minus 0 is 1. That just reduces to -3. And again, it makes sense that it's going down, or it's negative, because my graph is decreasing at that point. You could have done it by just looking at the graph. So I go down 1, 2, 3 over 1. Down 3 over 1. That's all we're looking for. All right, so I'm going to give you guys an opportunity to try this out on your own. Take a second, go ahead and get the x-intercepts and the y-intercept. So we're focusing just on this box to start. So hopefully, again, with the intercepts, you remember that I'm just crossing those axes. So I cross when x is 1 here, and then when x is 5 here. My y-intercept is when I cross the y-axis, which is along this line. And in that situation, y equals positive 5, which is that point there. Go ahead and tell me, is this graph positive or negative? How did we know that it was a positive graph? What gave that away? So now with our domain, we're asking ourselves how far to the left will this graph go and how far to the right. So again, these arrows mean it's going to go up and left forever. This means it's going to go up and right forever. So it's going all the way to the left and all the way to the right, which means, again, my domain is going to be negative infinity, which means all the way to the left, and positive infinity, which means all the way to the right. Let's actually just jump over to end behavior, because I also answered that. So as I move to the right, where's my graph going to go? As I move to the left, where's my graph going to go? And hopefully you put positive infinity for both of those, because again, it's going up forever and ever and ever. All right, go ahead and tell me, what is the vertex of this graph? What is the vertex? And once you get that vertex, tell me, is it maximum or a minimum? So we separate our graph into two areas. So we have this part, and then I hit this point here, which is what you should have put for the vertex, which is 3, -4. And then my graph changes direction. And that's what makes it a vertex. So your vertex was, in fact, 3, -4. And that should have been a minimum because I can't go any lower than that. Separate your domain. So negative infinity to positive infinity. In that blank, write the x value of your vertex. This is my green side, the left. This is my yellow side, the right. Which side is increasing, my green or my yellow? So you should have said your yellow, because your yellow is in fact going up as I move further and further to the right. So I'm going to write my yellow region here. My yellow region started at 3, right here when x is 3, and then it never ended, so it goes all the way to infinity. Based on that, we know that our decreasing interval is going to be my green side, which makes sense because as I move to the right, I start to go down. And that started at negative infinity and stopped when x was 3 at that vertex. All right, last one. Find the average rate of change. I'll give you guys a chance to try it out. Again, if it helps you use the formula, it's y2 minus y1 over x2 minus x1. So try that out. The two coordinate pairs we're looking for was when x is 1, which is here. So 1, 0, and then 4, where x is down here. So we'll go for -3. When you plugged all those in, your second y value was -3 minus your first y value, your second x value minus your first x value. So -3 minus 0 is -3, -4 minus, or I'm sorry, +4 minus 1 is +3. That's just a fancy way to write -1. All right, guys, wonderful job. Again, you're going to click the link in the Edpuzzle, and that'll open up the Desmos activity. Do your best. All we're looking for is your best. As always, send us a picture of your notes of your work and submit it to Google Classroom. Good job. Let us know if you have any questions.